The name of the experiment is the wavelength of laser light using a semiconductor laser. The aim of the experiment is to determine the wavelength of a given laser source by diffraction method. The apparatus required are a laser source, a diffraction grating, a scale. The formula used in the experiment are: the wavelength of a given laser source is determined by using the formula lambda is equal to d sin theta m by m, where d is the grating constant, theta m is the angle of diffraction, m is the order of diffraction. The grating constant formula is given by d is equal to 1 divided by number of lines per meter. In the present experimental grating, it consists of 600 lines per millimeter. Therefore, number of lines per meter is 600 lines per mm. You calculate that value, 1 divided by 600 into 1000, 10 power 3, which is equal to 1.66 into 10 power minus 6 meter. Then the angle of diffraction is given by theta m is equal to tan inverse of xm divided by r, where xm is the distance between the central maxima and the first order diffracted spot. R is the distance between the screen and the grating. So this is an experimental diagram, so which consists of a laser source, a diffraction grating, a screen. So you can able to observe that in the experimental setup here. So this is a semiconductor laser I am using in the experimental circuit. A semiconductor laser, a diffraction grating element, a grating holder, and a laser source. A laser source. Yeah. Now I'll come on to how to conduct the experiment. First, you need to set the distance between the slit and the screen. That is, the distance between the screen and the grating as 10 centimeter. That is R in the diagram. R is equal to 10 centimeter, which is constant. So later on, so incident the laser on the diffract grating pattern, then the light get diffracted. You can able to observe here. So this is the diffraction pattern, the central maxima, on either side of the central maxima, first order diffracted lines and the second order diffracted spot. So you need to measure what is the distance between the first order diffracted pattern with respect to central maxima. So this is xm, this is xm. You need to note down the value of 2xm. So therefore, you take the thread to measure the distance between the first order diffracted maxima. So you can note down, you can observe over here the distance of the first order on the right side and the left side. So without disturbing this distance, so you can measure what is the distance between first order diffracted spot. So use the same length without disturbing that, measure what is the length. So you are getting around 9 centimeter. In this particular case it is around 9.4. I will tabulate the same thing in the tabular column. You can observe over in the tabular column the distance R is equal to 10 centimeter, first order diffracted lines, the value of 2xm is 9.4. So now I will move on to the second case. So again, note down or you can measure what is the distance of second order diffracted spot. That is left side second diffracted spot, right side second diffracted spot. So this is the value of 2xm for the second order diffraction. So without disturbing the distance, so measure the distance. It is around 29. You can observe over here. It is around 29. The same value will be tabulated in the tabular column. The distance is same. Distance between slit and the screen is 10. Order of diffraction is 2. For second order, the distance is 29. So by using this, now you vary the R from 10 to 20 centimeter. So you can observe here, vary the distance from R is equal to 10 to 20 centimeter. Again, you continue the same procedure. So what is the distance of the first order diffracted spots? So by using the thread, you measure what is the distance between these two. Without disturbing that, you can measure what is the length. It is found to be around 18.5. I will note down the same reading over here. You can see the same reading in the tabular column for first order diffracted spot. For R is equal to 20. Similarly, you measure what is the distance of second order diffracted spot. So without disturbing the distance, measure what is the distance. So it is around 53 centimeter. It is around 53 centimeter. Note on the same value for second order diffracted spot. R is equal to 20. It is 53. So continue the same procedure for R is equal to 30. You must measure for first order diffracted spot what is the distance of 2xm and what is the distance of 2xm for second order diffracted spot. So this is how you must note down the readings. Later on, move on to the calculation part. You have noted the value of 2xm. Divide this by 2, you will get the value of xm. Then the angle of diffraction is calculated by using the formula theta is equal to tan inverse of xm by r. Xm is there in the tabular column, r is also here. Both are in centimeter. Just take the ratio and calculate what is the tan inverse. Later on, so calculate the wavelength of the light by using the formula lambda is equal to d sin theta m by m. So the value of grating constant already calculated. So it is 1.66 into 10 power minus 6 sine of the angle of diffraction from the tabular column for first order 25.17 m. Order of diffraction is 1. Calculate that value. It is found to be 7.06 into 10 power minus 7 meter for first trial. Similarly, calculate the wavelength for the second trial. So only thing is you need to change the order of diffraction from 1 to 2. Then the value we will get around here in this case is 6.83. So continue the same procedure, calculate the wavelength in all the 6 trials and get the value like this. Finally, take the mean value. It is found to be around 6.79 into 10 power minus 7 meter. So this is how you need to conduct this experiment.